Okay, so I wanted to go over this problem. Kind of ran out of time in class. Uh, let's see if I could sketch on this piece right here. So this was problem number 8, I believe, from your practice test. And what the problem was, it was asking how much of a change was there between the person who was standing here on planet X versus two diameters um, or one diameter actually up above the above planet X. And so if we look at it from a couple different standpoints, we can see that if we're on planet X, if we're on planet X, the the force of gravity can be interpreted a couple different ways. So one way would be to look at this person from the standpoint of our standard weight formula, which is the mass of the person times the acceleration due to gravity. In this case, the acceleration due to gravity was 16. Or we can look at it from the standpoint of using Newton's gravitational law. And Newton's gravitational law looks like this. And if we looked at Newton's gravitational law from the standpoint of um, the person being up in the air, up in the sky, uh, one diameter above the Earth, let me get to trying to use a different color, but I'll just stick to black. So if the person is one diameter or two radii above Earth, the gravitational force on him would be some unknown. And that's what we're trying to figure out. So if we now look at the force of gravity of that person one diameter up above the ground or above the air, and compare that to this 16 mass of the planet, we can kind of see that embedded in this formula, if we expand this out, this piece right in here, which is what we just found a second ago, is actually equal to this gravitational force that we found on um, planet X. Maybe I can call this FG1 and maybe this is FG2 so we don't get that too thrown off. But what I have right in here is actually FG1. And what we could do is we can make that substitution. We can make a substitution for just this part of FG1. And by doing that, we would just simply replace that piece that I have in that oblong circle, whatever you want to call that, replace it in here. Remember that 9 was that factor down below, and we could factor out that 1/9. So in essence now, I have that 1/9 times 16 is equal to the mass of the planet, um, or the mass of the planet, which I got over here, the mass of the person, times this unknown gravitational force. Now we can kind of see if we solve this for G, you can see that it differs by a factor of 16 over 9. And if we take 16 over 9, if we plug that into our calculator, we should get that value of 1.6. And those units would be meters per second squared. Okay. So you probably get, I think, 1.7, you plug it in, but using two significant figures, you would get this value. All right. So sorry I ran out of time in class and wasn't able to put the two things together. But you'll probably see something kind of similar to this on test number 2. Take care.